Hello everyone, Jake Peters from Hapeman Electonics here with a video on how to operate our portable speed sensor tester for locomotive traction motor speed sensors. As you can see, it comes in a yellow carry case like this. It's not always yellow, but this one happens to be so. It's got a computer inside of it, and it comes with, I'll show you, a cable that connects to the traction motor speed sensor. Now obviously this is not on a traction motor, it is actually on our simulation cart, which simulates a bunch of different traction motor and engine speed capabilities. So you can see over on the cart here where I have the cable plugged in. This is plugged into a active speed sensor for GE traction motors, notably the GE V13. And you can see it goes down on the cart here and is pointed towards it's kind of hard to see in the video here, but a 192 tooth traction motor speed gear. The speed sensor that we're using on this cart, as you can see in the tag, is an 84A207936 Part 2, which is common on GE traction motor, the speed sensor that they use on GE traction motors. You might have a P4 just because the P4 is the kind of reliability update from the P2. So basically what I'm going to do here is I'm going to spin the cart up to 1000 RPM, which will get the speed sensor going, and then I will show on the computer how to run the software to be able to see if your speed sensor is good or bad. So as I mentioned, I'm going to speed up the cart. So the first thing that you want to do if you're running this on a traction motor is get the traction motor spinning by whatever means you have, using a drive or whatever you're using in your shop on the shop floor to get the speed sensor or the traction motor spun up. Usually to around 1000 RPM is a good set point. You can run it at something below that if you want. The speed doesn't really matter. I just know that the 1000 RPM set point is something that we use most of the time. So what I'm going to do now is I'm going to spin up the cart, and then I'm going to go to the computer and show you how to run the software. Alright, so here we are on the desktop of the computer. You can see there's very little on here. This computer is literally just meant to run the speed sensor test. So what we're going to do is, you can see my mouse moving around here. We're going to go over and select the Speed Sensor 2020 with Pico program here. There's an older version of the speed sensor tester that does not have the with Pico option, and it was an older design, couldn't run as high as speeds when running the test. You had to go pretty slow. But this new version can pretty much go as fast as you want on the traction motor. So what we're going to do is we're going to double click on that to open it. And you'll see there's a login screen here where basically it just wants you, this is mostly for data recording purposes. It wants you to put in your username. So we can we'll put in Hapeman, and then you select what motor you want. We're selecting a GE V13, and basically what these motor selections do is they decide how many teeth it should be expecting on the gear that's on the motor. So GE V13 has a 192 tooth gear, and we're on 192 tooth gear on our speed sensor cart, so I'm going to pick that. And then it's asking you to enter the frame serial number. Because this is just kind of a demonstration, I'm just going to type in a bunch of 9s. We'll hit enter, and that will load the software. So now what I'm going to do is I'm going to spin up the cart, which will simulate bringing the traction motor up to speed. So we'll wait for a second for it to spin up. So you want to make sure that you don't try to run the speed sensor test while the traction motor is accelerating or decelerating, because it's going to obscure the readings. So right now the speed sensor is stabilized at around 1000 RPM, or our cart is stabilized at around 1000 RPM. So you'll see on the left hand side here there's two buttons. There's a run button and a run with analysis button. So the difference between the two is that the run button is going to essentially analyze the speed sensor pulses themselves to make sure that the speed sensor is okay. So it's going to check that all the pulses are there on all 4 signals. It's going to check that the pulses are the right voltage, that one pulse is leading the other properly, and so forth. Whereas the run with analysis is actually going to do a run and analyze the speed gear that's on the motor to see if there are any defects in the gear itself. Now, the speed gear that we're running on right now it's not set up to have any defects on it, so this is just going to pass. But I'll just give you an idea of what it will look like whenever you run a good test using the speed sensor tester. So what we're going to do is we're just going to click the run button, and it's going to run, and you see it runs really quickly, and it says passed. And what it's showing you here is it's showing you all 4 quadrature signals on the screen. You can see it's in blue, red, green, and yellow. And there's a little legend over here on the right-hand side of the screen that shows you which color is which. You can see that down here there's some numerical information about each signal, with information on what frequency it's getting, what the peak voltage is, what the duty cycle is of each signal, and all that goes into account of whether or not it determines if the speed sensor is good. And then over here you can see it tells you how fast we're going. So that says 1001.6 RPM, which is, we targeted right around 1,000 RPM. It's not, our cart isn't set up to be exactly 1,000, just to be close. So that gives you an idea of that. And then right here we have channel delays, which is another indicator of like which channel is leading which, how much delay is between the channels. And all these numbers are used to determine whether or not the speed sensor is good or bad. Now, one of the other options that you're going to see up here is that there's a button for counterclockwise and a button for clockwise. And this is in case you have the motor spinning backwards for some reason or whatever. You can change this, and if for whatever reason you test it and it says that it's bad. So you'll see, like right now we're running clockwise. If I click counterclockwise and then I rerun the test, it fails. It says channel 1, 2 bad, because basically now the delays are wrong. The wrong speed sensor is leading because we're running in the wrong direction. So it's saying that those 2 channels are bad. So I'll put it back to clockwise, which is correct for our cart, and we'll run it again. You'll see it says passed. Now, I'm going to run the speed sensor, the run with analysis now, which is going to look for any defects in the gear. And you'll see it does an extra step where it takes an initial collection and then it runs a full analysis. Also, this test is very fast, but it says that it passed, meaning that there are no anomalies in the gear. So that's essentially all that you do to run this test. And if you want to exit the software, you can just, like any other program in Windows, you can just click the X up here on the right-hand corner, and that's all you have to do to run the speed sensor tester from Hapeman Electonics. So I'm going to go ahead and spin the cart down, and you can see that the motor is spinning down to a stop. And that is all for the operational procedure for this portable speed sensor kit for locomotive traction motor speed sensors. If you have any questions, you can give us a call at 724-376-2239, or you can email us at hpelect@hapeman.com. This has been Jake Peters. Have a nice day.